This is Group 6's Waterslide Project. Our slide parameters. The height of the slide is 17 meters. The angle from horizontal was 11 degrees. The type of slide is an open serpentine. The size of supplying body of water is 140 meters cubed. The rider mechanism is we had a tube, slide material, polyethylene, and the age of the rider is 15 to 45.
Since there was room on the site for new rides, Holiday World seemed to be a popular place for us to decide to build a slide. We examined the property and determined that this park would provide a perfect place for the slide within the park. Building here would fill a vacant space while also utilizing the existing infrastructure to assist for installation costs.
We started the design process by figuring out an overall shape for the slide. We wanted to meet the serpentine requirement while keeping the design relatively simple. So we decided to split the 17 meters of height into three 5.67 meter sections. The first is a straight 11-degree incline. Next is a 180-degree helical curve with a 11-degree incline. And third, another straight 11-degree incline. To achieve the 11-degree incline on the helical curve, we had to determine the diameter of the curve using the helix equation, and that came out to be about 18.5 meters. Next, we selected the tube appropriate for our age group of 15 to 45. We sourced a 44-inch commercial water park tube from Tube Pro. Next, we modeled our slide inventor. We used a 54-inch diameter for the flume. The standard said for a tube slide that the minimum had to be 52 inches, so we went with 54 to give ample room for the riders. We modeled it in an inventor by extruding a cross section along the curve. It's 5/8 inch thick, approximately 90 meters overall length, and 6,344 pounds of polyethylene in total weight. Next, we used the Manning's equation to find the necessary flow rate. We started by setting a water level at a height of 2 inches. Using this, we plugged into an online calculator to find the wetted perimeter and the area of flow. And we plug this into the Manning's equation to get a velocity of 3.8 meters per second and 1065 gallons per minute. We compared this to the Excel sheet values afterward, which came out to be the same. We got the roughness, the coefficient for the Manning's equation from Engineering Toolbox for polyethylene, and that was about 0.012.
So we chose the Adanorm horizontal casing pump for our water slide. It's a pump that's usually used for slides, or it's advertised for slides and water features, with a maximum head of 300 feet and a drive rate of up to 600 horsepower and a max flow of 6,000 gallons per minute. We thought that would be plenty of room to be able to do with what we need. We have to have a minimum of 1,065 gallons per minute to run our slide. And this pump is a good choice for us because, like I said, it can go up to 6,000. And the pump was designed to use a little bit less energy, requires a little maintenance, and lifts small volumes of water to various head levels.
So to deal with the cleanliness of the pool and water slide, we decided to add a chlorinator. We chose to add the Autopilot ChlorSync Salt Cell CS50 chlorine generator. The CS50 has the capacity to chlorinate a 40,000 gallon pool, and our pool size was calculated out to hold approximately 37,000 gallons of water. This chlorinator should also be able to chlorinate the water in the pipes as well. Our group chose a Pentier filter with a capacity to cover the square footage of our pool and the 1,065 gallons per minute of our system. This shows that our filter will properly work for our water slide.
Moving on to the cost benefit analysis. So calculating the payoff period of the slide is a crucial process in order to accomplish this. The revenue of Holiday World as a whole needs to be examined in order to do this for our water slide design. So the table below provides a brief income breakdown for Holiday World. Just to name a few of the prices, the slide material of 6,344 pounds, we found is around $5,000. The top piping and the bottom piping, roughly the top piping will roughly be 5,000. The bottom piping of 40 feet be around $2,300. Um, and the construction and engineering cost come out to around $200,000. And then for the yearly cost, we'd have to have lifeguards and then total power, and that comes out around 61,000. And then the total cost with the 4 times factor would come out to around 1.1 million. And then when it comes to the revenue, the total revenue would be around 10.2 million. That includes tickets, season passes, photo passes, and food and beverage. That's based on our slide. So the installation of a new slide will probably boost park attendance. That implies that, or this implies that Holiday World can create an excitement for the new ride, and the slide is properly promoted. So by additionally selling more tickets, the park would see more visitors in other locations, which would result in higher sales of pictures and season passes, as well as food and beverage concessions. Only a third of Holiday World's entire season is spent with the water park open. So it's a shorter duration than the rest of the park, and it indicates that the slide might pay for itself in a little more than about 2.5 years. So in order to account for any unforeseen expenditures that the slide may have, the estimate should be increased to roughly 3 years for the payoff. And in conclusion, the Waterslide project covers all the topics and problems that we discussed in the course. The project gave us the direction we needed to build a water slide based on certain specifications and all the other elements required to finish the system. We had the chance to use engineering principles and work as a team to accomplish a deadline because of this. And the project entailed doing things that a qualified engineer in the field would do, such as looking online or requesting quotes from vendors to find out how much materials and components would cost. Everything had to be considered, from the materials needed to build the slide to the cost of the engineering construction. We were able to estimate like a payback period of 3 years, compensating for any unforeseen cost. So by looking into the overall revenue earned by Holiday World each year, we needed to make sure the pump we chose can manage the flow rate necessary to give users a comfortable ride. So we had to do a number of calculations. This is our works cited. Thank you.